So see students, the chain reaction is shown over here of that means this is a nuclear fission. See, this one is the neutron. Neutron is a chargeless particle of an atom. Then that neutron will be bombarded on the atom of uranium 235, and then the neutron will be increased by 1 into the nucleus of this uranium atom, and then the mass number will change from 235 to 236 like this. Now this uranium 236 is very unstable isotope of uranium. Isotope, I have taught you previously that isotope is the atom of the same element with same atomic number but different atomic mass number. So you can see that the atomic number is similar in both the uranium, but the mass number is different. That is, here it is 235 and here it is 236. And why here it is 236? Because one neutron has been added into the nucleus of uranium 235. And then what will happen, this uranium 236, as it is highly unstable, it will get converted into barium and krypton. Now this barium and krypton are another elements, and it will also release 3 different neutrons in addition to this, and lots of energy will also be produced of 200 mega electron volt. And now this 3 neutrons are free to get bombarded to the other atoms of uranium, and then this neutron will be bombarding to one uranium atom, then this neutron will be bombarding this uranium atom, this neutron will be bombarding this uranium atom, and this is going to be a chain like this. Then again it will be getting converted into uranium 236, here uranium 236, uranium 236. As is, all 3 are going to be unstable uranium 236 isotopes. These are going to be getting converted into barium and krypton, releasing another 3 neutrons, and lots of energy will be created. Then those 3 neutrons are free to be getting bombarded towards the next uranium atom, and so this is how it's going to be a long chain, and such kind of chain reaction is going to be there, which will give rise to tremendous production of energy. And then such kind of energy will be used for boiling the water into the boiler. Then the steam will be created, the steam will be drive to the turbine, then the kinetic energy of the steam will be converted into the electrical energy with the help of the generator, and this is how the electricity will be produced. So this is all these are the things which are going to be happen into the nuclear power reactor. Now see, here it is given that Kudankulam is the the nuclear power plant, or the atomic power plant, which is present in the state of Tamil Nadu with capacity of 917 megawatt. Then Tarapur, it is present in the Thane district of Maharashtra with 1400 megawatt. Then Rawat Bhata of Rajasthan, it is with 1180 megawatt. And Kaiga is the atomic power plant, or the nuclear power plant, present into the Karnataka state with 880 megawatt. Now you can see the schematic representation of the nuclear power plant. So this one is going to be the nuclear reactor. It is going to be a vessel in which the radioactive elements like uranium and thorium will be taken as a fuel, or the plutonium will be taken as a fuel, and these are going to be the control rods. Rod is much authentic word instead of pots, because these rods are going to be made up of cadmium, and these are for absorption of the neutrons, or the absorption of the harmful radiation. Then these are going to be, this is connected to the boiler. Now here whatever energy will be created, the thermal energy will be used to heat the water into the boiler, and this is how the steam production will be take place. Then the steam will be passed to this turbine. The turbine will be rotating, and then the kinetic energy of the turbine can be changed into the electrical energy with the help of the generator. Then whatever warm water is going to be there, that is going to be condensed with the help of the condenser, that will be cooled down. The steam will be cooled back to the water, and this is how the warm water will be going to the cooling tower. Here it will be cooled down. So this is how the schematic representation of the nuclear power plant is. So this nuclear power plant is quite beneficial because it will not create any kind of pollution, because it is not based on the use of fossil fuel, but it is based on the use of the radioactive elements. But there is one disadvantage, that it may give rise to if any accident takes place, the harmful radiations are going to be released into the atmosphere, which is going to be fatal. Fatal means death causing. So let's see which are the problems associated with nuclear power plant. The products after the fission of nuclear fuel are also radioactive and emit harmful radiations. So precautions are to be taken for proper disposal of such products or such waste. Nuclear waste is the very, this is a problematic thing to dispose the nuclear waste, because it is to be disposed very carefully as it consists of harmful radiation. So, or if any kind of accident takes place into such nuclear power plant, it is fatal. Fatal means it is death causing, because it can release harmful radiations into the atmosphere. So lots of precautions are to be taken whenever we are working into a nuclear power plant. So this was some of the problems, but but there are advantages also, that it cannot cause any kind of pollution and can create tremendous amount of energy. So this is how the nuclear power plant is. Rest of the things we are going to learn into next video. Till then, have a knowledgeable day. Thank you.